Okay, so in this video we're going to do the problem that's on your screen. And so this is a Calc 1 problem that maybe relates to optimization or maybe related rates. And so this is just how I'm thinking about it, and you guys out there that are smarter than me can probably think of a different way, maybe a quicker way to do this. But so here's what we've got. I've got Chicago sitting here somewhere. And so at noon we've got a plane that heads straight south, 500 miles per hour, so that plane sitting down here somewhere, and then another plane heading toward Chicago, plane sitting there somewhere. And so let's maybe label this vertical distance y, and then the distance that this second plane is away from Chicago, let's call that x, being a horizontal distance. Right, so we could say the distance that the first plane is traveling away from Chicago is increasing at 500 miles per hour. And the distance that the second plane is away from Chicago, x, is decreasing at 650 miles per hour. So that's negative. And of course our question is, when are these two planes the closest? So when is the distance between them, which I'll call r, when is that distance a minimum? So the way I'm going to try to tackle this is I'm going to try to set up r as a function of time, and then it just boils down to taking the first derivative. So let's see if I can express r in terms of the variable t. Right, so of course we can use the Pythagorean theorem to express r in terms of x and y. Right, we've got that. So if I could get x in terms of t and y in terms of t, then I would have r in terms of time, and from there I think life would be relatively easy. So a little bit of I guess differential equations, not too heavy on the differential equations, but so we are given some information about the times here. I'm going to let time 0 represent noon. So what that tells me is that my distance y, the first plane at noon, was in Chicago, so at time 0 my distance from Chicago was 0. And for the second plane, well, the second plane arrives in Chicago at 2 p.m., so at noon, if it's traveling 650 miles per hour, it must have been 1,300 miles away from Chicago. X is the distance away from Chicago. Right? If it took 2 hours to get there, going 650 miles per hour, it must have been at a distance of 1,300. So we can really easily get y in terms of t if we just integrate both sides with respect to t. Take the integral with respect to time on both sides. Right, so that'll give us y equals 500t plus c, and right, this being the initial value of y, right, we know that has to be 0, because at time 0 the distance was 0. So we know that this is 0, and so there's our expression for y in terms of time. And I can do the same thing for x. I'm going to integrate here with respect to t on both sides. So that gives me, of course, negative 650 t plus some other constant. We could call it c, maybe call it c1, because technically it is different than the last one. But again, that constant just turns out to be the initial value here of 1300. Right, and so here's our expression x in terms of t. Now you might have just been able to set those up algebraically. I mean, if you know that this first plane is traveling straight south at 500 miles per hour, then this would simply be the expression that you would write. I mean, even my Algebra 1 or college algebra students maybe could figure that out, right? So because after 2 hours, the plane has to be 1,000 miles away from Chicago, right? So if t is 2, then the distance away from Chicago is 1,000. Or same thing here, you might have just been able to figure this out without any calculus or differential equations. If we're starting at noon, then after 1 hour, we would expect that the plane would be 650 miles out because it arrives in Chicago at 2 p.m. And this equation seems to give the right result. 1 hour after noon, the plane is 650 miles out from Chicago. So maybe you didn't need differential equations to figure those two out. But the point being, now I can go back to my expression r squared, and I can plug in what I found for x and y. So that would give me something that looks like this. I can get my page to scroll down. So we'd have r squared equals x squared plus y squared Now what I want to do is find the minimum of the distance r. I didn't write that very well, r squared. I want to find the minimum of the distance r, so in order to do that we could take the square root of both sides, but knowing that I'm going to end up wanting a derivative, r squared will have the same minimum as r. So what I usually do is this. I usually just minimize the square of the function. Right. So maybe we just call this rs or something like that for r squared. The minimum value will occur at the same value of t. Right, so in other words, we're going to get rs prime, set that equal to 0, and solve for t. And then we should have the answer to our question. So I'm going to use the chain rule, bring the exponent down, multiply by the derivative of the inside. So let's see, we can do the chain rule here as well. I might have been better off to just go ahead and simplify this using the exponent too, but we can use the chain rule as well. That's fine. 2 times 500t to the first times the derivative of the inside. So this function simplifies to, let's see, I'm going to multiply 2 times minus 650 times minus 650, which should give us 845,000. And then we've got 2 times 1300 times minus 650, which is 1690 0, 0, 0. And then what here? 500 times 500 times 2, t, which is 500,000. T. Right, so a nice linear equation. Just add these two like terms, and that should give us minus 1690, 0, 0, 0. And to get the minimum, of course, we're going to set this equal to 0 and solve for t. Assuming everyone can handle the algebra from that point, you should get a value of approximately 1.26. That was our time, which should be in hours. So I think that will be the time at which the distance between the two planes is a minimum. And then the second part of the question was, what is the distance between the two planes at that time? And you can use your relationship for r to figure that out. We would come back up here, plug in our value for time, and then of course remember that we would want to solve for r, so we would want to take the square root of the number that we get over here once we plug in our value for t, which is 1.26. So I think once we have found that time, we're well on our way to answering the second question. And I think I'll stop the video there, as we're getting close to the maximum time that I have for the video anyway. So anyway, I hope that helps.